All right, we're back with 8.1 Swyk 2. I had to split the last one because I thought I could get more done. All right, we're talking about an arithmetic series here, and we can see the common difference between the terms is 5. Any term minus the previous one will tell you that common difference. We can see we're adding 5 each time. But we don't know how many terms there are, so that's step number 1. Find out how many terms there are. So let's see here. We set the last one equal to 2, the first term, plus the common difference, times n minus 1. So you can see we're going through the process of solving this. And let's see here. We subtracted the 2, got 55. We divided by 5 and got 11. Added 1 and got 12. So we know there's 12 terms. What do those things add up to? Now, we could sit there with a calculator and keep and write out all 12 terms and then add them up. That is not what we're going to do. Not at all. We're going to find a faster way to do that, especially if there's 1,000 terms. We don't want to keep doing that. Hold on and I'll show you what we're going to do. But first I need to tell you a story from the late 1700s about a little kid named Carl Gauss. Carl was a genius, a mathematical genius. Way smarter than me, I'll tell you that. When he was in the first grade, he got in trouble with his teacher. His teacher said, "You're going to stay in from recess and you're going to add the numbers from 1 to 100. Well, little Carl walked up to the slate chalkboard and wrote the answer. Well, so how the heck did he do that? Let's see what little Carl saw. When you write out the numbers from 1 to 100, or even just a few of them, like the first ones and the last ones, and you start adding the pairs at the ends, like what's 1 plus 100? 101. What's 2 plus 99? 101. What's 3 plus 98? 101. It keeps doing that. How many pairs are there? Of course, the answer is 50. So, little Carl there decided to take 50 times 100 plus another 50. Okay, and that's how he got his answer. Or 50 times 101. But, smart little kid, huh? Here's the formula that Carl Gauss came up with. In order to be able to handle doing this formula, you need to know the number of terms, how many terms there are. That would be what, so we use a capital S sub n to stand for the sum, right? The sum of the n terms. All right, so if we know that there's, in this case, 100, we would put S sub 100. Well, so n is the number of terms. A sub 1, we know that's the first term. What we don't know is A sub n, that's the last term. Well, in this particular case, yes, we know the first term, we know the last term, we know how many terms there are, and we can use this formula. Now, I commonly refer to this formula by Carl Gauss's rap name. I know, you don't think kids from the late 1700s had a rap name. I call it Lil Carl. So when you hear me refer to Lil Carl, I'm referring to this formula. Okay? Very useful formula. Lil Carl. In fact, I'll say things like, we have a finite arithmetic series. What does that add up to? And I want everybody to scream at home, Lil Carl! That's right, folks. Finite, meaning it has a stopping point. Arithmetic means there's a common difference between the terms. Series means you're adding up all the terms. Sorry, don't want to yawn. Okay. Next problem. Wait a second, we didn't finish that problem. We figured out there were 12 terms, right? So let's figure out what we're going to do with that. We know that there are 12 terms. 12 divided by 2. We know the first term's a 2, and we know the last term's a 57. So plug them into the equation. So that makes 59. 12 over 2 is 6. Multiply those together. Whammo, 354. The sum of all 12 numbers is 354. It works very nicely, whether you have 12 terms or a million terms. So, great formula to use. Next question. Why isn't it moving up? Okay, there it is. So this one starts out with summation notation, right? It's saying that we're starting at the first term and we're stopping with the 80th term. And then they give me a formula, an explicit formula. Now, if you don't know that this is an arithmetic series, here's a couple ways to figure it out. Number one, look what you have inside here. It's a linear function, mx plus b. That's a dead giveaway that you're dealing with arithmetic. But if that still doesn't jump out at you when you look at this, then what I suggest you do is start by plugging in 1, 2, and 3. If you plug in a 1, you get -4. If you plug in a 2, you get -2. If you plug in a 3, you get 0. The first three terms are -4, -2, and 0. Well, you can see that it's going up by 2 each time. That's a common difference. That means it's arithmetic. So, it's a finite arithmetic series. What is that up to? Well, Carl, thank you very much. So, we need the first term. We already know there are 80 terms. But we need to find the first term. We already have that, right? -4. We figured that out over here. And the 80th term, right? You just plug in an 80. You'll see that I drew arrows at the beginning here because I'm plugging in a 1 to find the first term, plugging in an 80 to find the last term. And now I can use little Carl's formula, right? We know that there are 80 terms, 80 over 2, -4 is the first term, 154 is the last term. Plug it in, multiply it together, we get 6,000 in this case. That's what you get when you add all 80 numbers together. Question 6. We've got 120 terms, so we know it's finite. It's a series, right, because you're adding up all the terms. And we got another linear function. Why in the heck is that the same function? But it is. So I don't pre-program these things. Math Excel spits them out for me. Once again, if you didn't know the terms, you would plug in a 1, a 2, and a 3. If you didn't know, if you can see that it's linear, you automatically know it's arithmetic. So finite arithmetic series, that adds up to Lou Carl. Thank you very much. So we know that there's 120 terms. We know that the first term is -4 because we plugged in a 1. We plugged in 120, and if you plug in 120, you get 234 for the last term. And now you can plug it into the calculator. 60 times 230 ends up giving me 13,800. And that's the end of this Swyk. Talk to you on the next Swyk. Bye.